Let's take a look at a trivial example where the client has been burdened with creation. In this example, I have a main where I have an array of strings. I create a client object and I ask that client object to read the shapes from that array and then draw out all the shapes. And we see that the string that represent the shapes have to be mapped into the creation of the correct object type. We see that this is a working application. If I run it, we get as an output drawing a rectangle and drawing an oval, which maps to the strings that we passed into the client. The creation is dynamic, so if I add another rectangle to the array of strings and run it, we'll see that we get another rectangle created also. And if we open the client, we will see the use of polymorphism, but also a suboptimal algorithm for creating objects. Now, the first thing we notice is that we have a list of shapes which have no knowledge of the various subclasses. It's a list of the abstract type shape. Then, when we draw the shapes, we're taking advantage of that and we're simply looping through the shapes and telling each shape to draw without knowing whether it's a rectangle or an oval. We were not able to take advantage of polymorphism in the read shapes, though. Here we have the client that is mapping the pound rect to the creation of a rectangle or pound oval to the creation of an oval. In other words, polymorphism doesn't work for creation of objects. When we create an object, we have to know exactly what class we're creating. Now, this is a huge problem. Let's say we introduce a new kind of shape, say a line. What will happen now to the clients? All clients that is involved with creation of object will know how to change their algorithm. Let's say, for instance, in the example we had, we add another shape, a line as the last item. For that to work, we would have to go into the client and change its code. That means that we have a really bad isolation of change. The introduction of a new class into the hierarchy of shapes requires change to the client also. So in this example, I need another clause to this if-else statement that looks for a line and creates a new line. Now you can imagine if we had several clients, they would all have to change because we introduce a new kind of shape. If I run the program now, it will correctly create the line as we see, but we don't like this. If a change requires changes to the code in multiple places, that's a suboptimal design. So what we want is to move this knowledge of this mapping away from the client and into the shape hierarchy. What the factory method pattern suggests is that we move it in as a method on the most abstract type. And from Java 1.8 and onwards, you can add a method directly to the interface. However, in this example, I'm using Java 1.7. And for that, I need to change the interface into an abstract class to make this pattern work. So let's move the creation algorithm from the shape class into the static method on the base class. Now that we're operating on a single shape, I'll just make a simple return value and I'll assign the return value to the appropriate instantiation of the class before returning it from this method. Also, because we're using Java 1.7 and I had to do this with an abstract class, obviously I need to change the classes to extend the shape instead of implementing a shape. And we have an error here where I used the wrong variable name when I did the copy and paste. So I'll change the variable name to s, which is the string parameter coming in. And we also need to change the algorithm of read shape now. Since we now have the switch statement or the if then else statement in the class method that we created on shape, we can simplify this significantly. And it looks very much like a polymorphic constructor at this point. The client is no longer burdened with knowing about all the subclasses of the hierarchy. And we have the equivalent to a polymorphic constructor. This pattern is called factory method. And this is when we create a method, typically a static method on the most base class, that is responsible for knowing how to map some external context into the correct subclass in the hierarchy. Now all that remains is to try it out, so we'll run it And we see that indeed we get the same result, but now with a much simpler client. So the general solution here is that we are taking away the burden of mapping some external context to the correct creation of subclasses from the client by simply introducing a static method on the most base class that does the creation on behalf of the client. That way we can localize all that behavior to the hierarchy itself.